Good evening to one and all present here. This is Darageshwari, working as Assistant Professor in the Department of Electrical and Electronics in Mohammad Sadak AJ College of Engineering, Chennai. On behalf of Mohammad Sadak AJ College of Engineering, I welcome all the participants for today's international webinar on building automation and HVAC controls. I find immense pleasure in introducing our honorable resource person, Mr. Nishant Murthy. He did electronics and instrumentation engineering in RMK Engineering College. He have been working for Honeywell as a building automation project engineer for the past 5 years. It's a pleasure to have you for this webinar, sir. Now I request you to take over the session. So, thank you.
Hi, good evening and welcome. Before I begin, I would like to thank Mohammed Satak Engineering College, Manju ma'am and Professor Venkatesh sir for giving me this opportunity and coordinating the complete event. My screen is on the left side, so I'm gonna close the video for now. We'll take over to the session. Thank you. I hope everyone could see my screen. A quick note, I want you guys to enjoy the session, make it interesting and useful. I don't want to be a regular boring classroom lecture, so I promise it's going to be useful. So make sure you take something new or some new learning after the session. Okay. If you have any comments, I hope you'll type in the private chat or in the comment section window. All right, let's begin. A quick disclaimer I used to put up in all my presentation. So again, make the session useful, interesting, something new learning for you. I hope it's going to be interesting for you guys. If at all it's boring or something like that, just type in the chat window. We'll try to switch over the topics. Okay. All right. So as introduced, this session is about HVAC system and building automation system. We'll cover the first half with regards to HVAC, and then we'll go to the building automation system. For many of you all, this might be a new topic. This has been the field or industry I've been working for past 5 years. HVAC system is as abbreviated as heating, ventilation, and air conditioning. This is majorly for life survival. HVAC system was invented or discovered to give comfort to human beings. In extreme weather condition where it's too cold outside or too hot outside, human needs survival of specific comfort zone, a perfect humidity level or a temperature level to get inside for the comfort zone. So that's why HVAC was invented. Uh, for a quick note, the perfect temperature level for a human being or the comfort zone we call this 21 to 24 degrees Celsius in the tropical countries like India or the Gulf countries. In the Western, we call it 70 to 74 degree Fahrenheit, where it's measured in Fahrenheit. So that's your comfort level for a human being. Okay, so let's say it's minus 50-degree cold winter in Canada or like 60 to 50 degrees Celsius in the Gulf countries. It's hard for survival, and that's why HVAC system was invented so that human beings can live inside the comfort zone in a building or a closed space. So we'll go upon how does it work or what are the mechanical equipments in an HVAC system. So this is a beautiful picture I found online, which tells you pretty much every mechanical equipment in an HVAC system. Go from your left, where it says outside air. Now that particular box is called air handling unit or AHU. I'll explain in detail down the slides what each equipment will, what's the purpose of each equipment is. So ventilated room is a example of a closed space. Let's say it's a space or a building. You need AHU, you need a chiller, you need a boiler, and a cooling tower. So these are the four ideal or mechanical equipment for a HVAC system in a building. All right. So yeah, how on what principle or basis does it work? Okay, if there are people from mechanical background or a E&I background, you might know the thermodynamics principle of heat transfer, conduction, convection, and radiation. So your HVAC system completely operates on this principle, majority on convection and radiation. So let's say there's a hot pipe going through your building, you can feel the heat radiated through it, right? So that's your radiation principle, and convection is your transfer of fluids. Like if there's a hot water, it goes down like your heater or a geyser. So majorly it operates on this thermodynamic principle of heat transfer. So we saw about the components of HVAC system. Now we'll go one by one in detail. If you have any questions, you can stop then and there, and I'll try to explain. If I'm not able to answer, I'll research on it and get back to you. Okay. First is AHU. As I said, it's called air handling unit. Second is chiller, boilers, heat exchangers we call it, energy recovery wheel, and your terminal units. So, I'll just tell a brief note about it. AHU is nothing but the ultimate purpose defined by the name air handling unit. The purpose of it is to serve air. It's just like your ceiling fan. Now, since it might be a new topic for many of you or a majority of you, I'll try to correlate the topics or the concepts or equipments in HVAC with your day-to-day daily life. Let's example in your home. Even there's an HVAC system in your home, not as much as it is, but the simple concepts you see in your daily life. So I try to correlate so that I can understand even better. All right. Terminal units, chillers is for your cold water, chilled water, boilers is for your hot water. Energy recovery wheel is just a energy saving concept. We'll not get into it detail, but I thought of mentioning it. Terminal units are FCUs are called fan coil units. VAVs are called variable air volume units. Again, we'll see in detail one by one. If I'm too fast, please stop me. I'll try to slow down. Okay. So this is your typical or ideal graphical representation of an air handling unit. So this is not how it looks. I'll show you in the next slide how AHU looks, but this is how we show in the front end or an HMI how AHU operates. Like a SCADA or something like that. So again, as I mentioned, the typical purpose of an AHU is to supply air to a building. You need airflow, right? So the major component of an AHU is a fan. You need fan to pump in air from outside or from rotate the fan inside the building. As I said, you can compare HU to a ceiling fan. Consider this as a ceiling fan. The only purpose is to serve a air to the building or to the closed space. Okay. So you can see other components like dampers. Dampers are a very important component of an HU. You can consider them as navigators. Okay. Consider them as windows in your house. There is a fan operating and there's a window before it. Only when you open the window, the outside air will come in or the inside air will rotate. So outside air dampers is to get the outside air into the building. Your return air damper, as you can see, is to circulate the air inside the building. Let's say there is corona outside. So during in all corona season, all the buildings will operate on outside air because they don't want to circulate the inside polluted or the let's say it's an hospital. They will not circulate the air inside the building. They will bring an outside air damper. Buildings like cinema theaters or complex mall, they'll circulate there within the building, so they'll close the outside dampers. So your dampers are important component in AHU. They act as a navigator whether to get the outside air or the return air. So again, you can compare them to windows in your house. If you want outside, you'll open the window. If you want to circulate the air within your room, you'll close the window, right? So dampers are similar to your windows. Now return fan and supply fan are just like your ceiling fans. So that's a major component or the purpose of the AHU. So some AHUs might have supply fan, some AHUs might have both the fans. If it's a big building, since the supply fan cannot rotate the air within the building, they'll have return fan to pull in the air from the building and to circulate it. Okay. So those are your fans and dampers. You can see something at the bottom called cooling coil and heating coil. As the name defines, let's say if it's too hot outside, you want cold air inside your building. So you'll operate the cooling coil, which is just a chilled water from your chillers. We'll see chillers in detail later slides. And again, if it's in winter countries where it's too cold outside, you'll operate the heating coil so that you'll circulate the hot air to the building. So this is just a basic concept of an AHU and the complete HVAC system. There's human being inside the building. You can take every building, a big building. We call it a centralized air conditioning in India, but it is called as HVAC system. That's it. So your centralized air conditioning system is called as HVAC, but with too much of thermodynamic science and controls to it. So that's your complete package, right? So if it's too hot outside, you want to operate the human beings in 21 to 25 degrees Celsius. You run the AHU, your chiller supplies your cooling coil to the water. You get cold air to maintain the perfect temperature level. Now, if it's too cold outside, you'll run the boilers. You supplies heating coil to the hot water to the heating coil, and it gets your comfort zone. So that's your complete principle behind it. So we'll switch on to the next slide. So this is how your AHU looks. This is a picture taken from one of my site currently I'm working on. But it's a big box. All you have is two fans inside. If you see on the I cannot use a marker here, but I'm sorry. If you see the white piping, it's your water pipeline coming from your hot water I'm sorry, chillers, boilers, and yeah, we have something called humidifier. I'm not getting into detail with that, but we'll just stick with chillers and boilers. So you have three piping on your left, right? Starting from the first. The first one is your cold water from chiller. The second one is your hot water from your boiler, and the third one is your humidifier. And your silver plated or coated thing above your AHU is called the ductwork. That's how huge it is. So one is the return duct and one is your supply duct. One comes from the building, one goes to the building to supply. So just your big box, consider this big box a ceiling fan. It supplies to the air and it gets the air from the building. That's it. All right. I cannot take pictures inside, but each door you can see doors, right? Like one is open and the rest of the closed. Each component or a compartment of the AHU goes to one department. See, let's say there will be one door for cooling coil, there will be one door for heating coil, one door for the dampers, one door for the fan. So those are called component or compartment of the AHU. So if you get inside, that's how big it is your coil. I mean, actually, this is a pretty much decent size for a three-floor building, which supplies about 20,000 to 30,000 CFM. So yeah, that's how big your coil or your fan will be. All right. Any questions? All right, we'll move on to the next slide. So we saw what is AHU. We'll switch over to the boiler system. Boiler system is it's pretty much again. I'm comparing to your just take your gas stove in your house. What does it do? If you on it, it's gonna fire. It will eat up anything. Okay. So similarly, you know pretty much normal. How does a normal boiler works? It's gonna eat up your water in it. In most of the cases, it's gonna be steam. Again, there is a beautiful picture on your right which explains the complete concept. There will be a boiler. It has a fuel. It's gonna fire up the boiler. We have valves to supply the fuel and everything. It will convert your water when it's heated at high temperature into steam, and that steam gets supplied to your H. Sometimes it's gonna be direct water without converting into steam. Sometimes it's gonna be steam. Now your steam goes into the building. It again gets converted into hot water, and that goes into your AHU. Mostly, we determine the hot water temperature based upon outside air temperature. If it's too cold outside, we increase the hot water temperature. If it's at moderate temperature, we maintain at 100 to 110. Again, countries like tropical countries like India or Gulf countries, we predominantly don't use boiler. There is no purpose at all. Sometimes in the northern Delhi, Jammu, Kashmir, you'll find boilers, and but in Western countries, boiler is a must. Every house will have HVAC system, and every house will have a boiler. Boiler is a must in all the countries on the West. But in India, we air conditioning is must nowadays. It's getting into every household, but boilers is not suited or not much needed for our country. All right. But again, all these are for survival to make human beings, because the temperature goes below zero most of the times during winter. Boilers are must for human being survival, and that's why HVAC is so important. All right. Again, just to brush up again, boiler is just like a gas stove which eats your hot water, and that hot water supplied to the HU for hot air. Chiller system is much more complex or complicated than a boiler system. It's not as easy as a boiler. People from mechanical background or E&I background should have known this already. We call it as vapor compression cycle. This is how your refrigerator in your house, this is how your split AC, your window AC, everything operates in your house based on this cycle. So I'm not going to get into detail again, but this is a typical VCR cycle you should have known. You must have known. So this is the principle that the chiller operates on. We have a refrigerant in a chiller. There is so much principle or government rules and laws behind it, because they cause the greenhouse gas, and they are bad to your depletion layer, ozone layer. So I'm not getting into detail again, but the major thing used in a chiller is your refrigerant, which cools your water to a very low temperature. And the principle behind the chiller is again your vapor compression cycle. So To explain this in simple, I'll say if you have a AC or a split window AC in your unit, we have two units, right? The one which is mounted in your room, the one there's another unit which is mounted in your ceiling or outside your building, right? So this evaporator section is the unit which is mounted inside, and this condenser unit or the part which is mounted outside your house. So that's your condenser unit. So this is again the principle behind in a chiller. So chiller can be classified into two types. We call it as air cooled chiller and water cooled chiller. Okay. So on what basis we classified? Let's say, for example, the split AC, we call it as air cooled chiller because if you see the picture on the left, there are multiple fans on the above, right? So, and there is a bottom cubical or cylindrical structure. We call it as the evaporator part. So there is a refrigerant inside the evaporator part which cools the air or cools the water for the building, right? So now that refrigerant needs to be cooled, and that is taken care by your fans. And in water cooled chiller, you use cooling towers to cool it. Instead of the fans, we use water to again cool your refrigerant, but there will be a fan in the cooling tower too, but not but along with water with it, not just fans. I'll explain you in detail. There's a beautiful picture on the next slide which tells you the whole difference about. So this is a sketch representative of a chiller or a cooling system completely in detail. So I'll take you part by part. If you see there's an air handling unit on your right, which needs cold water, and that chilled water or cold water is being supplied by your electrical chiller, let's say. And again, as I explained, it has two section, condenser section and evaporator section. All right. So what runs between this condenser section and the evaporator section is your refrigerant. There are multiple variety of refrigerant based upon the greenhouse gases and everything. Now, so this refrigerant in the evaporator section will cool your chilled water supply based upon again the thermodynamics principle, convection and radiation. Okay. Uh, Now this refrigerant, once it cools the chilled water supply which goes to the building, now that gets heated up. Now that again needs to be cooled. So that is taken care by a condenser. And again, the water from the cooling tower will cool the refrigerant in the condenser part. Now, this is a whole complicated operation. So, if you're not getting any point, let me know. I'll try to brief on it again. So again, if you see the cooling tower, if it had been an air cooled chiller, you'll just have a multiple fans above your condenser section part. You won't have this cooling tower at all. Since water is being used to cool your refrigerant in your condenser, it's called as cooling water cooled chiller. If it is just fans which is being used in the condenser to cool your refrigerant, it's called air cooled chiller. All right. Now just look into this sketch in detail, and if you look into this picture, you'll know. So if you see the carrier picture, the one above, that's your condenser, that's your old part. The bottom one is evaporator. If you put up multiple fans about that carrier part, it's called air cooled chiller. If you have a cooling tower and which is supplying water to cool the refrigerant in the condenser part, it's called water cooled chiller. All right. Only water cooled chiller will have cooling towers. Air cooled chiller will not have a cooling tower. That's what I'm trying to get in here. Any doubts? Any questions? All right. There is two principle where the apart from the vapor compression cycle, the VCR cycle, which I showed you earlier, there are other two principle where the air cooled chiller and water cooled chiller operates. Air cooled chiller operates on the principle of heat rejection. Okay. Let's say a simple concept. Let's say you have a hot coffee. Now the refrigerant inside the condenser hot. Okay. You blow. How do you cool your coffee? You blow air into the coffee, right? You take a cup of coffee. If you blow air, it gets cooled in 1 or 2 minutes, right? That's the principle of air cooled chiller. There are multiple fans, and the fans keep on rotating to cool the refrigerant inside the condenser. That's a principle of air cooled chiller. When you just blow your coffee, the coffee gets cool. So it's called heat rejection concept. Now take a air cooled chiller. How do you cool the other way of cooling your coffee? You take another cup, you pour into the cup, and keep on constantly pouring between the two cups, right? If you tea a tea master, how does he cool the tea? He keep on pouring between the two cups. That's called evaporative cooling. So that's how air cooled chiller works. So what happens I have another picture from my side which I'm currently working on. I'll show you. You can understand. So the water goes to top of the cooling tower. There is a fan above. The water gets sprayed, and the fan. Let me show you a picture. Probably you'll understand. So this is your air cooled chiller. You have a refrigerant in your cup. Say it's a condenser. If you blow air, there's a fan above the condenser. It keeps on blowing air. It's cool. It gets cool. So that's your heat rejection concept for your air cooled chiller. Now let's say water cooled chiller. This is evaporative cooling method. what happens? The water from the condenser goes to top of the cooling tower and it gets poured. And your fan, there's a cooling tower fan. We call it a fan. You might ask, there is a fan on both the air cooled and water cooled chiller, but here there is no water. So that's a major difference between there's a cooling tower water which goes about to the top of the cooling tower. The fan gets rotated consistently and the water gets sprayed down so that the heat is being rejected. We call it as evaporative cooling. All right. And I'll show the real pictures of my. So again, this is your cooling tower. I try to sneak in the pictures from your left. Go from the left. So that big box is called your cooling tower. All right. So what is inside is a big fan. So that's your cooling tower fan, which keeps rotating all the time. And if you can see on the left in the third picture, the black thing, that's where it's called coil. That's where your water gets poured on the sides. And when you keep on rotating the fan, your evaporating cooling method, your water gets cooled. All right. Just think it a similar concept to your tea master. That's how I explain in simple terms. So there's a fan above the tea master. It keeps on. If you pour the water between two cups, it gets cool. Evaporative cooling method. And if you just blow air into the cup, it's called heat rejection method, which is called air cool chiller. So that's the difference between air cool and water cool. I'm stressing on cooler because chiller and cooling tower are very very important part of HVAC system because it's pretty much used in every country, irrespective of winter or cold. Every country needs cold and chiller. You can see HVAC system without a boiler, but definitely not without a chiller. If you go to big buildings or any shopping mall or any IT building in Chennai, you will see cooling tower top of the building. Every building needs a cooling tower. Okay, any shopping mall in Chennai or any big buildings which has HVAC system, you'll find a cooling tower and a chiller system. All right. So yeah, that's complete concept about chiller, boiler, HVAC, which is a major equipment of a HVAC system. You need air. For that, you need AHU. You need cold air. For that you need chilled water, which is by chiller. You need hot air. For that, you need hot water, which is by boiler. All right. So now I said something else. Terminal units. Terminal units are nothing but, let's say there's a big system which is consistently supplying air. Now there are small units for each room. Okay, your AHU, boiler, chiller are major equipments which are mounted in the basement or top of a building. Now there are small rooms in a building. There's a conference rooms. There is a break room. The AHU cannot supply air into every room. There will be ducting. Ducting are like your like piping. For water, we need pipes. Your chiller or boiler supplies water to the AHU through piping. So all piping again, piping and ducting are important components. For air, we call it as ducting. Ducting is the one which carries air from AHU to all parts of the building. Now there are spaces where the AHU cannot supply enough air. So in such units, we mount something called fan coil units, which are let's say a minimum. You can call it as a table fan. Your HE is a ceiling fan. Your fan coil unit is a table fan, right? So fan coil units are a small units, a packaged unit which supplies air to a space where it is not being able to reach by the AHU. It has a fan, it has a filter, it has the same heating and cooling coil, right? So that's your fan coil. We call it as a fancy name, fan coil unit. But again, it's a simple mini AHU which is being supplied to room where the AHU is not able to supply to it. All right. So you can see it does not get ducted or being supplied by the AHU. It's an independent unit which supplies to a independent room. Now, how does the other rooms in a building gets ventilated or air from? So this is another a nice picture which shows the purpose of a VAV box. There are two major terminal units. Fan coil units one, which is an independent mini AHU, and there's another unit called VAV boxes or variable air volume boxes. Now the only purpose of this unit, it's a small box which has a damper in it. All right, and this box gets air from the AHU. Let's say there is 10 floors in a building and each floor has 10 rooms. Okay, so the AHU supplies air to each floor, and each room will have a variable air volume boxes. So the only purpose is to save air, and it has a damper in it. Now this operates on the principle of cascade control. Okay, all it has is a damper and it has a temperature T stat in it. So let's say, look at a picture on your left. Each room has a box in it. If you see the ducting work, the duct work goes to each room individually. There's a circled part which says VAV diffuser box. That's a VAV box. Now this duct gets your air from your AHU. So each room has a T stat. We call it as thermostat, a temperature control. So what happens is if you go into the building, you go into the T stats, you adjust your thermostat. You might have seen in some conference rooms or in your the seminar rooms, you'll have a temperature control, right? So if you adjust it, what happens? It's just a ceiling fan. You have a regulator in your fan. If you feel too cold, what you'll do? You'll reduce the speed of the fan, right? Similarly, if the room is too cold, what you'll do? You'll adjust the temperature, and the VAV box will gets automated based upon the programming and control. It will adjust its damper position to lower the airflow coming into the building. I'm sorry, into the room. Okay, so if the damper is closed, which means there is no airflow. So when you're too cold, you'll switch off the fan. So the damper will close automatically. When it's too hot, you'll put it in your full speed. So the damper will open automatically. So the damper operates, it's just like a window concept. You'll open, you'll close. So the damper modulates accordingly to increase or decrease the temperature in the room. It's actually controlling the airflow, which affects your temperature. That's what we call it as cascade control, controlling your temperature by controlling your airflow. So which has two control in it. So that's a concept of VAV air volume. To brush up again, your AHU supplies air to the VAV. Your VAV will control the temperature in the room by controlling the damper position, which in turn controls your airflow. All right. The picture is self-explanatory. We have inlet, outlet, damper, and actuator. Actuator is a controlling equipment for your damper and valve, which I'll explain in your upcoming slides. So this picture will explain you completely how does a HVAC system operates. Try to zoom in. So let's say there's a building. It is split. We have your So this outside unit is called, yeah, we call it as outside unit, rooftop unit, AHE unit, RLE unit. It's just a different name, but the concept is you have fan inside. It supplies air flow to your complete building. You can see the ducting going through each floors via VAV boxes. So that's your complete airflow side. And now your AHE needs cold water and hot water. You can see the cooling tower at the top of the building, which supplies to your cold water to your chiller. Your chillers are in the basement. If you see there's a chiller, there's a boiler, and this supplies your hot water and cold water to your AHU. Apart from it, there are many other small equipments in AHU which is not covering in detail, but your exhaust fan for your kitchen, or let's say there is some hot room serving and you need exhaust fan for your data centers or toilet systems, or we have energy management system. This is what I was telling about energy recovery wheel and other components. And apart from that, we have EV charging station, motor light. All this comes in building automation system, which will come in the upcoming slides. But with respect to HVAC system, it's AHU, exhaust fan, cooling tower, chiller, boiler. All these are mechanical system which is running on the basis of thermodynamics principle to keep human beings in the comfort zone. That's all I wanted to take you from the HVAC system side. All right. Any questions so far? Okay, great. All right. Hmm. So we saw what are the major equipments, but apart from this, what runs the fans and the pumps? Your pumps are your just like fans for airflow to circulate. We need fans, right, to pump in. For chillers and boilers, now the major equipments are pumps. That's the one which keeps on pumping water from the chiller and boiler to the HU and back to the system. So these two are important components in the mechanical equipments, which again runs on all your motors, DC, AC motors, strand motor, and there are multiple motors based upon the principles or usage. We use different kinds of motors. Dampers, again, just like your windows, they are navigating device. They are the one which decides if a building needs airflow. If the dampers are closed, no, even if the fan is going to run, you're not going to get the airflow inside the building. So dampers are very important. Valves for your water flow. So it's again just like dampers, valve for your water flow system. The valve is closed, you're not going to get water flow throughout your building. Just remember this: ducts and dampers for your airflow system, valves and pipes for your water flow system. Okay. Coils are nothing but it's just if you guys have seen a window a window air conditioning unit, at the back of a unit you can see black thing running between, or your fridge, the back of a refrigerator you'll see coils, right? That's how coils, but in a different uh, design in an AHU. That's where your cooling chilled water or hot water goes through the coils, and when the airflow passes through it, it gets converted into cold air or hot air based upon the principle of convection and radiation. All right. So again, this completely runs on thermodynamic principles. Piping. So Psychometry chart. I'm not going to get into detail, but I'll tell you this. We are not using psychometry. It's an old concept. Nowadays, we have application Android app to determine your dew point, dry bulb temperature, and everything. These are the technical terms we use in HVAC field to determine uh, to identify some uh, temperatures or humidifying factors, sensible heat, latent heat. All this falls under thermodynamic concepts. While designing cooling tower or what designing HU, all design engineers will use the psychometric chart. I just want to let you know that this is one important concept or principle people use in HVAC field. All right. This is a chart. If let's there are seven factors. I'm sorry, six factors. Wet bulb temperature, dew bulb, dry bulb, moisture content. If you know three factors, you can identify either one in this chart using this chart. It's an again important chart in the HVAC field. Right. So to put up in an old concept, uh, we have AHU, which is nothing but it supplies airflow to your building or your closed space. So consider it as a supply fan or a ceiling fan. Now, what does it do? It supplies airflow. Now, let's say it's too hot outside. What do you need? You need cold air. So where do you get? You need cooling coil. When your airflow passes through your cooling coil, you get cold air. And where do you get the cooling coil or the chill water from? You get it from your chill water system. And it's classified into air cooled chiller and water cooled chiller based upon the type it is cooling your refrigerant inside the condenser, right? So I hope you're clear till this. Now, let's say it's too cold outside, you need hot water, you need hot air. Okay, so now when your supply fan supplies air into the hot heating coil, you'll get your hot air. Now, where do you get your hot water from? Boiler. So this is you put everything in a box which I showed you, it becomes an AHU. So that's your complete concept is all about. All right. I hope you're clear with this concept. So this is your simple explanation of your HVAC system. This is the simplest explanation you could ever get. I tried my best. I hope you understood this. Apart from this, you have terminal units like VAV and fan coil units, which serves your individual rooms. But your major components, which you can file in your basements or your ceiling of every building, or your chiller, HU, and your boiler. All right. Now, all these are mechanical equipments. Okay, your ceiling fan is a mechanical equipment, or your boiler, your air conditioner, your refrigerator. All these are mechanical equipments. If you turn on the power, it's gonna operate. Now, what does it to do with the building automation system? This is a slide which I created for E&I. I hope it will be up. Anyway, so your building automation system plays a huge role to control all your mechanical equipments automatically. Let's say there's a ceiling fan and there's hot outside. You go and switch on the fan. When it's hot outside, you go and switch on the air conditioner. Or when it's too cold, you go and switch off. You have to do it manually. So what if there's a automated system which does it on its own? Let's say it's a building. Let's say take a huge building. What's the biggest building in China? Let's say LAC building or Express Avenue Mall. There should be hundreds of people go on controlling each and individual shopping complex, each and individual room, right? Let's say there's 1,000 rooms or 10,000 rooms. You can't go an individual room to switch on and turn on the fan or air conditioner or IHU. So that's where building automation plays a huge role. It does take controls of the mechanical equipments, AHU, chiller, boiler on its own. There are controls, there are sensors. We design it to there's a sequence of operation. We design the controllers to take care of its own 24 into 7 365 days on its own. All you have to do is just monitor. So that's where building automation system comes into picture with regards to HVAC role. Not just HVAC, but also there are multiple aspects it comes into a building automation system. You might have heard the term saying green building, smart cities, green cities. All it comes into this building automation uh, package. So HVAC, I explained you, heating, ventilation, air conditioning. The only purpose is temperature control, or we call it as comfort zone for human buildings inside a closed space or a building. Security is which we call it as which covers your access and CCTV. Access means your card reader, your biometric sensor, all this comes under security. Fire system, again, it's a life-saving system. Your smoke detectors, let's say there's a smoke in a building, okay? The smoke detector detects it, automatically shut down the HU, automatically fire extinguish. Everyone should have heard about sprinklers in a building, it sprays water. All these are done automatically. Energy system. Nowadays, energy is booming into the world. Everything is energy saving. Any AC conditioner or any refrigerator, everything is energy. So it's again a different level package in a building automation system. Lighting. You can think it's a simple system, but lighting is again a different level of based up nowadays. All IT companies are getting into lightning level. Let's say there is a meeting in a room. The light level, the intensity of the light level gets immense or dimmed automatically. The luminescence is reduced according to the let's say there are so many people in a room. The lighting level is reduced and increased based upon the sensor in the room. So that's what it is all about. But again, I've been experienced totally on the HVAC field. I've never got the opportunity to get in the other aspects of building automation system. I'm predominantly experienced or learned on the HVAC field. So I'm going to cover with regards to HVAC for now. Hopefully later in the later upcoming session, I'll try to cover the other aspects of building automation. Okay. This is a simple level picture explaining what are the package you cover in a building automation system. Most of it, uh, energy system. If you can see camera, it's a security system, access system, Wi-Fi. Those again, access system, Wi-Fi, smart security, HVAC, lighting system, water system, temperature. So everything. There is no person to monitor. You install the system, you control it. There are multiple controllers, devices, sensors. You have to design it, program it accordingly so that the building runs on its own without anyone's operation. It takes care. All you have to do is design it accordingly, and it's going to take care of its own. Imagine you're away from your home. It's like 35 degrees Celsius outside. Before going into home, your air conditioner turns on automatically. It's going to maintain a 21 degrees Celsius. All you have to do is once you go into home, it turns on automatically. So that's automation is all about, right? You don't have to go home, turn on your air conditioner, wait till it gets to 21 degrees Celsius, half an hour. By the time you'll be already pissed off already. So that's the purpose of automation. Let's say it senses your location. By the time it comes on, it turns on. So you can add many number of aspects and scenario. All you have to do is design it accordingly, and the building takes care of its own. All right. So we'll break down one by one how it's done. Uh, again, as I mentioned, I'm going to take care with respect to HVAC field. So let's say this is your simple picture explaining how it's taken care by the building automation system. This is simple as schematic. If it's people from E&F field, you should have known it already. For others, I'll try to explain. Control output, control sensed variables. These are three aspects to control something in your HVAC. Okay, I've been just mentioning about temperature because that's how I can compare you to your daily day-to-day life. But there are so many aspects in HVAC field. We'll control the pressure in a boiler, the pressure in a chiller. We control the flow. We'll control the level in a cooling tower. There is sometimes humidity in the room, and there is viscosity, and there are so many parameters we control and monitor in a HVAC system. Okay, so I'm just considering a sensed variable for now, just in a general term. We have a sensor which keeps on monitoring or measuring whatever input you want to control or monitor, which goes to your controller. You might have heard the term PLCs and DDCs. Your DDC are direct digital controller, PLC are programmable logic controller. So it gets the input. Okay, so which gets the input, and your control output can be a actuator, can be a VFD or anything. So basic concept is, you let's say you want to control the temperature in your room. You have a split unit, right? So it has a temperature control in it. It measures the temperature. Let's say if it's 25 above, it measures it, it cools it accordingly, and it controls your damper or your flow control from your split turn unit. Okay, you can sometimes use it to swing direction and everything. So that's your controller. There will be some microprocessor inside the split unit as well, so we call it as controller. It gets input, it measures the input and gives the output. That's the whole concept behind it. You need a input, you need a controller, you need a set point. We use sometimes, if you keep it as, you adjust your set point in a remote, right? Everything is taken care by the controller. You do not have to do anything, and the output is to your damper or your valves or your actuators. Now, what feedback is important concept in your control loop. So to consistently adjust your output of your controller. Now, if you see the picture on your right, it has explained. So let's take it as an AHU. Your there's a heating coil. Your air flows from the supply fan, it goes to the heating coil. Your sensor is here. We call it as discharge air temperature. It measures your temperature from your AHU consistently. Now, let's say you want it as at 30 degrees Celsius from your, it's too cold outside, you want 30 degrees Celsius from your AHU. So it keeps on measuring the sensor. If the temperature is too low, it gives feedback to your controller. Okay, and the controller gives output to your valve actuator. So the heating valve gets open to your 100 position. There's too much of hot air from the heating coil. Now, when the sensor measures that it has reached the set point of 30 degrees Celsius, it gives feedback. Okay, so again, now it tries to reduce the close the valve. So that's your concept behind your control feedback concept. Any doubt so far? Okay, great. So this is your old concept or your principle which operates on your HVAC building automation system. Three parameter sense variable, control output controller, and it controls every other parameter or variable in a HVAC field. So what are the different types of inputs we come across? As I mentioned earlier, we have temperature, we have humidity, we have pressure, we have flow. We don't deal pressure or flow in your day-to-day daily life, but temperature and humidity you should have heard about. Humidity is a very important concept. We in tropical countries we may not deal with it, but if humidity is too low or too high, it's really a life-threatening parameter for a human mankind in a comfort zone. Okay, pressure and flow, it's not for comfort zone, but we deal with chillers, boilers. If the pressure is too high in a steam, it will explode. So it's very important to maintain pressure. You would have heard the concept exploding in a boiler room or a chiller room. It's because too much of pressure. So maintaining pressure at a particular psi or a particular inches of water is very important. Flow, you might have seen in your water tanks or any sum system flow measuring stations, right? So we do measure flow. Again, flow is an important concept. We have to maintain a particular GPM. We have different parameters, metric system, SI units. We measure different units in different countries. So these are four important parameters or a sensed variable we use in a HVAC field. Apart from that, there are other parameters too. Sometimes we call it dew point temperature, viscosity, or there are other temperatures we measure in HVAC field. So, what are the different outputs we come across? Actuators, we call it actuators. Again, your dampers and valves are your mechanical equipment. So what is the electrical equipment which controls your dampers and actuators? Okay, so we actuators are the one which controls your dampers and valves. Let's say you want to open a window, you go and open the window manually. What if you put a motor or actuator to a window and you send a command signal from a controller to the window? So that's the purpose of actuator. Let's say it's too hot outside, you need natural outside air. So the controller senses the temperature in the room and it automatically sends command to the actuator, and the actuator opens your window. So that's the complete concept behind it. Similarly to your valve, let's say it's too cold, you want to take bath in a hot water. Okay, so instead of opening the tap, let's say the tap is your valve. Your actuator, the controller will send signal to the actuator, and the actuator will open the tap automatically and you get hot water. So that's the concept behind it. Okay. Relays and contactors. Relays and contactors are important mechanical or electrical equipment in people from triple background should have known it. Contactors are for your IE equipment or high voltage switching devices. Relays are for your low voltage switching devices. Mostly building automation system runs on low volt 24 VAC or 24 VDC. So mostly predominantly we use relays. Contactors are used for pumps and fans and high voltage switching equipments. Okay, so your controllers, let's say you want to turn on the fan. Okay, let's say switches, you have switches, right? Instead of turning on the fan manually, your controller sends a temperature, it turns on the fan manually through relays and contactors. So your, again, as I said, there are three important parameters in building automation: your input, your controller, your output. Controller is your DDC or your PLC or any simple microprocessor. Your inputs are your temperature sensor, flow sensor, pressure sensor, and your humidity sensor, whatever. It senses, it monitors, it sends input to your controller. Your controller will send output to your output devices, which are actuators, relays, contactors, and VFDs. Actuators for your dampers and valves, relays and contactors for your pumps and fans, fans for HUs, pumps for your chiller and boilers. Now, what are starters and VFDs? Okay, so in olden days, I mean not olden days, like few years back, we had starters. Okay, your relays will not go directly to your pumps directly. There will be a in between devices called VFDs. People from again triple background should have known it. Variable frequency drives to control the speed of the pumps and the fans. Okay, so what your controller does is for small equipments, exhaust fans, we turn on the fan on and off. That's it. But for pumps and fan which runs on high voltage, we do not just use on and off concept. We adjust the frequency of the pumps, so 0 to 60 hertz, which is done by the controller. We send 0 to 10 signal, a voltage signal, which converts into 0 to 60 hertz in the frequencies, which in turn adjusts the speed of your pumps or your fan. I hope everyone should have known the concept, so I'm not getting into detail. So these are your major output devices which connects to your mechanical equipments. Again, these output devices are controlled by your controllers, which is being again sensed or given input by your input. So that's your complete concept. All right. With regards to E&I or control signals, these are a different control signal which gets from the input devices and gives output to the output devices. So let's say temperature. All your temperature are mostly RTD and thermistors. Uh, uh, People from E&I background should have known it. I'm sorry for the other department. We use different kinds of temperature sensor, NTC 20K, again PTC, NTC concepts, voltage signal. Most of your controllers, predominantly majority of your controllers in the field or in the industry, use 0 to 10, 2 to 10, and 0 to 5. There are some controllers which use current signal 4 to 20. Again, you can convert your current signal into voltage signal by adding a resistor, so it's not a major difference. uh, we are living in 2020. Almost many comes with wireless sensor, Bluetooth, Zigbee. I have not experienced right now because let's say I deal with a building with 1,000 rooms, 2,000 rooms. If you use every equipment wireless, there will be a huge traffic. So if whenever you go to a big building, everyone uses wired sensors, wired controllers due to the traffic and security concern. Anyone can hack into your IoT or wireless sensors. So it is safe and secure to go with wired sensors, wired controllers. If it is a home automation system, just one room, one hall, one kitchen, people use Bluetooth, Zigbee. But when it comes to a big industry, big building automation system, it's always wired and safe and secure. Pressure sensor, pneumatic sensors are olden days, not many are using it. If you go to big industrial automation, you might see some pressure sensors, oil and refinery industry you can see. But with regards to building automation, pneumatic signal, pressure signal is a whole concept. So we are pretty much with electrical and digital signal nowadays. All right, so these are your typical control signals. Uh, so this is a typical control panel you can find in a building automation system in a Honeywell. All those, the lightning thing you can see, all those are digital direct controls. I think it's pretty messy. So yeah, we do not deal with program logic controls. PLCs, distribution control systems, are mostly for your industrial automation, in where you can find in oil refinery systems, your big plants, cement plants, sugar refining plants. For building automation system, most industries, Honeywell, Siemens, Schneider, majority they use DDC, digital direct control. That's your current trend in the industry. So this is one example of. If you scroll down, you can see, so those small cubicle thing below at the bottom of the panel, those are your relays. So again, from your the sensors will be on the field. It will be on the HU. It will be in your rooms and everything. Relays will be mounted in the panel. This is your panel. So all your wirings which goes to the controller, or your wiring from your temperature sensor, pressure sensor, and everything, and all your wire, or the other part of the wirings are your outputs. So the bottom one are your inputs. The above one of your controller are outputs, which again go to the field like actuators, VFDs, and everything. The bottom one's your relays, which turns on your fans and pumps and everything. Okay. Any doubts so far? I'm not monitoring the comments. I'm sorry, but if you have comments, I'll get back to you. All right. So we have deal with all your electronical equipments, controllers, sensors, output devices. How do we design it? Okay. So this is one typical example. This is how we design. Okay. Your controllers is the brain of your building automation system. It will command it's like you're controlling or monitoring thing. It will say what to run, what not to run, what to turn on. It will say if the damper has to open, if the fan has to on. It does it automatically. Now, how does a controller do this automatically? You should have learned about come across microprocessor, microcontroller, some programming languages you should have learned already. So this is your, if people have come across MATLAB, some might have known MATLAB. There are numerous designing tool in the field, in the industries. This is one Honeywell proprietary tool, which is only Honeywell uses. This is not open source. So we use this to design based upon the sequence of operation. We call it a sequence of operation because there will be a set of instruction. Let's say there's a building in Chennai. Okay, so there's a sequence designed by the building client. They say I want this building to run 24/7. I want this building to run only on weekdays. I want this building to run only on the weekends. I want the AHU to turn on when there's two out outside. So they'll have a set of operation or instruction, and according to that, we design in the controller using this soft designing tool. We use it function blocks. Some examples are LabVIEW, MATLAB, Visuals. There are some tools which runs based upon C++, Java too, and there are some which rest on flowcharts, algorithm. Algorithm, right? And or commanded, if, for, if, or whatever. So there are numerous designing tool which you give us input to the controller. You code it, you design it, you program, whatever the name you call it. You have to design in the controller. You have to fetch in the sequence of operation into the controller based upon different types of designing tool. And once you download into the controller gonna run on its own throughout. You don't have to monitor or operate. All you have to do is wire the inputs and outputs of the controller, design your sequence of operation, download into the controller, and that's it. It's gonna take care of its own. That's how we call it as AI. Artificial intelligence is nothing but once you design and download into the controller, that controller will measure your parameters and everything. That's it. Let's take a air conditioning unit as an example. Okay, let's say that it's a conference room and there are two splitter units. Okay, uh, let's say there is an occupancy sensor in a room. Okay, if there is no people in the room, your controller will measure the occupancy sensor. Let's say there is no people, it will automatically diminish the intensity of the light in the room. Okay, let's say if there are five people, it will increase the intensity of the light, and accordingly it will increase the split air units. Well, let's say if there are more than 10 people, it will turn on your second split air unit. We'll call it as duty standby. Not every building will have one AHU, one chiller, and one boiler. There are huge campuses. I've dealt with sites where there are 20 buildings, 30 buildings. They will have 10, 15 chillers, 30, 40 boilers, 10, 15 AHUs. So they run on duty standby basis. If the load is more, we call it as building load, right? So we call you should have heard the term called tonnage, 1.5 1 ton, 1.5 ton. That's your refrigerant measuring capacity of your chiller. Okay, so let's say there are two, three chiller in your building. If the load is more, if there are more people coming in, they'll turn on more chillers. So that's how your controller operates. It keeps on turning on. So everything should be designed in the designing tool. Dump it or download into the controller. It takes care of its own. So this is that's how your controller will operate. Your controller will not operate on its own. You have to design it, the sequence of operation. The sequence of operation is nothing but how your building operates. When should it HU turn on? When should the light come on? When should your access door open? How does it decide who when you put the access card, which door opens? Who gives the access? So now I'm not just telling about HVAC, fire security system, access door system, CCTV system. Your camera can sense let's say there's a camera in front of the door. Every access door will have a camera. That's your thumb rule. There should be a camera in front of every access door. Let's say you walk into a door, you don't even need an access. The camera will detect your face automatically and the door will open. Let's say you don't want to open your door for your relatives. It will detect your faces of your relatives. The door will not open. So all this is being designed in the controller. So your controller is the brain. And how does it get the input? You have to design in your control tool. It can be any tool, LabVIEW, MATLAB, anything, but you have to fetch in the uh, control design to your controller. Okay. Any questions? You see, I think I hope you can see it. People in the control field or E&A background should have known a PID control, PID loop control. I'm giving in an input. This is a temperature. This is your set point, and so when to enable the PID, when not to enable. So this is a basic. All these are, if you can see on the bottom left, analog input, analog output. All your inputs will be your temperature, pressure, humidity. analog output will be your valve dampers. Binary input will be your statuses of your fan. If the fan is running, anything zeros and ones are called binaries. uh, Binary output will be a fan and pumps. Anything that is modulating 0 to 100 are called analog. I hope everyone in the engineering knows basic between difference between analog and binary, right? So that's it. So all these you should design the software tool, and in the field you have to wire them up. Okay. Hmm. Any doubts so far? Oh. What is Alexa and automation? Are you asking about Amazon Alexa? It's just a voice modulation. Okay, if that is a question, instead of coding everything, it will get your voice input and it gets loaded up. That's a individual team who modulates or listen to your voice of Alexa. They get the input and they design it accordingly. Is there any specific recommended control system like ABB, Siemens, Allen Bradley, only which this HVAC platform works without any breakdown? Not really. Every HVAC system is good. It depends on the client. Let's say the client says I want ABB, I want Siemens, I want Honeywell. There's a bit. Let's say there's a new building being construction. During construction, they will bid for the automation system. So multiple clients will bid for the project. Honeywell, Siemens, ABB, Schneider, whoever who gets the bidding, they will provide the automation system. That's how it works. Okay. All right. Last part of the building automation system, HMI, SCADA, front end, different names. HMI is human machine interface. SCADA, super control, it's a big name, front end. So super control and digital acquisition, I believe. Yes. So what this is just a graphical representation for the user interface. What does it do? It's nothing but a graphical view, just like an Android app. You can, let's say nowadays you'll get an Android app for your home automation. You can monitor your car. Your Tesla has an app, right? You can turn on your car from your app. You can turn on your AC from your home app. So similarly, there is a big front end for every building where there will be an operator engineer monitoring from the system. You can't go and we have buildings with 20 floors, 30 floors. There are skyscrapers in US, New York City with 100 floors, right? You can't keep on climbing 0 to 100 every day. So there will be, excuse me, there will be something called control room. In that control room where the operator or the engineer will be able to monitor every single sensor in the building. Okay. You should have known ITC Grand Chola, right? So I think it is done by Honeywell System, which is in Gindi Katipara. That building has 10,000 sensors inside the building. There are more than 1,000 rooms in the building, and there are 8 conference rooms. They cannot monitor each and every individual. You know how big it is, right? So they cannot go to individual room to monitor the temperature control. Let's say there is someone room in the science floor. They call up the control room and say it's too hot, there is fire inside. Everything will be monitored from the control room through the front end. So your front end is very important when it comes to operator and monitor. They can turn on a fan, pump, valve, damper. They can reduce the hot temperature in a room. They can reduce the flow, whatever they can control from the front end. So your front end is your user interface between the operator and engineer, where they can monitor the complete operation of a building. They can shut down the building in one click. They can turn on the building in one click. Okay. So your front end is your complete user interface between your operator and the building. How again we have to design the graphics for, we have to design all the graphics, show every point in the building. Now again, I've shown the old package of HVAC system in a different way. So how does a building okay, before we got one more slide. Communication protocol. So how does a sensor talk? How does a controller talk? We have different let's say your app runs on Android, your iPhone runs on Mac, right? So if we have different operating system, we have different communication protocol. So similarly, each controller has different. BACnet is your general building automation control network. Your BACnet abbreviated as Building Automation Control Network. Almost in 2020, predominantly all DDC operates on BACnet communication protocol. Some legacy or old communication protocols were LAN talk, Modbus, Profibus, all these are different communication protocols. But right now, almost majority building automation provider Siemens, they have BACnet communication protocol. Now the CBus N2 is CBus is Honeywell's individual communication. We are not using anymore. It was old communication protocol. but the one which is listed on top four are your majority, which is being used in current industry in the market. Okay. So that's one slide I want to touch base upon. All these are different controls being provided by Honeywell. We have different product line. Just like take an um, um, manufacturer like Hero or Maruti Suzuki. You have different models, right? So similarly, Honeywell provides building automation. We have different models of controls for different purposes. If it's a small building, we have a small control. If it's a big building or multiple buildings, we have multiple controls based on that. All right. Uh, think we are running short of time. Apart from that, we do different aspects in building automation, calibration. Let's say a control sensor is not reading. Let's say the temperature is actually 23 degrees Celsius, but it is measuring 25. So we have to go and measure it, adjust it accordingly to make it read good. So that we call it as calibration in an instrumentation industry. We have to calibrate each and every individual sensor. Apart from that, we have something called trend analysis and tuning. Let's say a pump or a fan is not acting good, or it's not performing good. So we have to monitor individual points. Can zoom in this. So we monitor the status, speed, feedback, pressure, damper status, everything on the. This is a front end. This is how a front end looks, but this is a trend analysis screen. So we monitor every points on the front end, make sure it's operating good, and we tuning. Tuning is an again important field or a concept or a. It's a part of instrumentation industry. You have to tune it so that the damper or the parameters maintained good. We do that through trend analysis. This is a transformer. People from triple background should have known it. So power supply is very important. Any control, any sensor, any pump, everything needs a power supply, right? Without power, you cannot turn on anything. So power supply is very important. This is a transformer which step downs from I think 480 VAC to 24 VAC. Okay. So all our controllers, all direct digital controller operates on 24 VAC, 24 VDC. As I mentioned, building automation runs mostly on low voltage systems. We never deal with high voltage system. All your pumps, fans, chillers, boilers runs on high voltage system. So this is your step down transformer. Valve characteristics I'm not going to cover. This is again for your instrumentation background. Okay, so we saw the whole package of HVAC system. Now we'll see the whole package for your building automation system. So we have all your mechanical equipments, AHU, chiller, boiler. This is your door. If you can see the axis, so door is your mechanical equipment. Let's consider. So there is mechanical equipment. You want to control that. You don't want to turn on manually. So what we use sensors to measure your flow temperature, let's say security of access control, your door access, biometrics at the bottom, cameras, smoke detectors, all these here end devices or monitoring control, measuring control. So all this will be mounted inside. All your temperature sensor, pressure sensor will be mounted inside the HU. Honeywell will mount it. All your security cameras, all your biometrics, everything will be mounted. Honeywell will do it. Honeywell will not, or Siemens, Schneider will not manufacture or deal with mechanical equipment. We deal with only electronical end devices. So we mount all this on your mechanical devices. Okay. Now we have our controllers. So all this end devices monitoring control will be wired to your controllers as inputs. We have to measure and monitor to your controllers. Now what are the controllers? DDC and PLC. We deal with DDC. Okay, PLCs are for your industrial automation for oil and refineries. Now what you do in controllers, you have to design using a design control tool, dump in your software based upon your sequence of operation. When do you want to open the door? Whom do you want to give the access? Whom we want to give the access to the door? When do you want to turn the HU? When do you want to turn on the chiller? What is the intensity of your light? When do you want during the daylight you want to turn off the lights? During nighttime you want to turn on the lights? Everything is automated. Your complete building is automated through your end devices, which is being designed in your controllers based upon your client requirement. Now, all your controllers, I have missed one part. All your controllers will go to your output devices, which is your VFDs, actuators for your valves and dampers, relays and contactors for your fans and pumps, or the output devices. Now, this complete thing is being monitored through your HMI and SCADA front end by your operator and engineer. Now, once everything is installed, commissioned, and downloaded, your front end is your go-to access. Let's say If you see at the picture, this will explain now. You can turn on, turn off everything through your front end. You can give access. Let's say you stuck at a door in the 10th floor building, and there's a control room in 100th floor. He can give you access to the door by just one click. He can give you access to any door by just one click. He can shut down the AHU. That's why nowadays all buildings are secure. Let's say it's on Wi-Fi, it's on internet. I can turn on a building from here in Chennai. I can shut down the access when it's on internet. So buildings have to be secure, and it has to be not open access to everyone, because you can let's say there's a fire in a building, okay, and you shut down all the doors in the building. People can't go out. Okay, so you can turn on the access to a building, or shut down the AHU. It's very, very life threatening and very danger to human beings if it is not secure. So the buildings have to be secure, because anyone can access the front end and create chaos and danger to the occupants in the building. We call it as occupants. So occupant comfort is very important when it comes to building automation. Any questions? There are three questions in the comment slide. SBO to EBO 3-point technology is advisable BM. Shivash, I'm really sorry. I'm not aware of the term, but probably I'll research on it and get back to you. If the current is shut down or no generator is also available, then how would our access door get access? Brilliant questions. So we call it as electromagnetic. Most there are different terms when it comes to access. Again, I'm not from access field. I'm from HVAC, but as much as I know, we call it as electromagnetic doors. Okay, so there will be electromagnet on the top of the door. When there will be program accordingly when to turn on, when not to turn on. Your access will always get generator powered up in emergency. Even if there is no generator, I think it's fail safe to open the door in all the time. That's how they program. It is a thumb rule to have generator for the electromagnet for the access door. If they don't have generators, they have to open it. If there will be multiple doors, right? Let's say 10 doors. They make sure that all your data center doors will be locked when there is power failure, and all your exit doors will be open. So that's how they programmed it. Let's say 8 doors is your exit entry, and 2 doors is for your data centers, or where our high expense equipments are kept. Those 2 doors will fail close during power loss, and the rest of the 8 doors will fail open during power loss. That's how they program it. It's again based upon the client. He will tell which door to be fail open, which door to be fail loss during power generator. This applies to valves and dampers as well. Okay, in Western countries, if there is no power, that's again a good question. If there is no power, all your heating valves will fail open, because they need hot water all the time. All your cooling valves will fail close, because you don't want to run the cooling valve all the time. If it had been India or Gulf countries, all your cooling valves will fail open, all your heating valves will fail close. So it's again based upon the client region you design during power loss. Power loss or power failures is very important parameter you have to consider during designing of your valves, access door, and your dampers, controls, everything. What the equipment has to do during power loss, that is important factor you have to consider during designing. What was the other question? The damper MOV is on and off for 420 control. The damper, again, it depends on the equipment, depends on the purpose. Okay, let's say it is a exhaust fan. All you have to do is just on and off. You don't have to control your exhaust fan. There will be a damper for your exhaust fan. Okay, all you have to do is uh, turn on the fan on and off. And if it's a outside damper, return damper, you will modulate them 4 to 20, 2 to 10, or 0 to 10. Okay, so depends on the purpose. If it's outside dampers valves, it's modulating signal 0 to 10, 4 to 20. If it's just a two position, it depends on it. I got two more slides to show. Yeah, thank you. This is again all these different fields with instrumentation. We control system, process control, transducer. Pretty much everything you learn in E&I applies to HVAC industry, building automation, industrial automation. You will definitely deal with everything you learn in your engineering. Okay, anyway, so you know what the last slide would be. I think I answered every questions. I want you guys to take this useful, interesting, fun, not a dip. I hope you guys enjoyed the session. If you have any questions, type in. I'm gonna answer. If not, I'll definitely get back to you.
Participants, if you're having any question, please post in the comment box.
I'm not providing any internship, but there are so much. The building automation field is booming in India. One pretty important line is HVAC is mandatory in Western countries. They cannot live without HVAC. European or America, Canada, you cannot live without HVAC. Every home has HVAC system. It is life survival. But in India or tropical countries, you can live without HVAC. HVAC is not mandatory for life survival. You can just sleep on a terrace or a room just with a ceiling fan because our climatic condition is like that. So climate condition plays an important role, but that is with respect to HVAC. Building automation has more than HVAC. You have access, fire and security, light automation, parking garage. Now electric vehicle industry is booming, so they are integrating that to building automation. So now Prime Minister Narendra Modi has boomed 100 smart cities. Honeywell is taking part of it. We are some part of smart cities. We monitor a number plate recognition system in every city, traffic signal monitoring. All this comes under building automation system. We the water treatment plant, with not just dealing with HVAC, but there are numerous fields when it comes to building automation systems, smart cities, traffic monitoring, number plate recognition, road and repellent system, Wi-Fi, smart system. So there are so many fields. If you research upon, there is no prerequisites. If you are from electrical instrumentation, triple E, or mechanical, I think these three departments cover fall under HVAC and building automation system. Or even if you are from electrical communication, any electronic field with good knowledge in BMS, we call it as BMS or BAS, building management system, or building automation system. So these two field, if you study on, if you research on, I'm pretty sure you'll get good opportunities or into this field. Voting concepts? I don't think so. No, there's no such voting concept. There will be a design consultant who will design the sequence operation for the client, and that's your bidding document, which we get as input to our building automation, and we design the drawings or the inputs and everything based upon your bidding document from the design consultant. Uh, Software tools. Once you research upon, you will get to know. To start off with, just go through. There are brilliant tools by Siemens, Open Learning, Schneider, Honeywell. There are so much open learning for building automation. So start off with the basics, go through the concept, and that should be your stepping stone to get into the field. I think I'm done here. If you have any questions, you can email me or contact me. Yeah, you got the email address. Yes. So if you have any questions, reach out to me. I'll try to do my best to answer or anything that could be helpful. I hope you guys enjoyed the session. Uh, I hope it's useful and interesting. Thank you very much. Thank you, Mohammed Sata College, again, Manju ma'am, the management, and uh, the professors for reaching out to me. Thanks for the opportunity. You have a good day. Stay safe, and thank you.
Yes, sir. On behalf of Mohammed Satak KJ College of Engineering, I thank our chief guest, Mr. Nishat Murthy, for gracing his precious time and sharing his wonderful experience in the field of building automation and HVAC controls. We look forward to see you again for the upcoming webinar, sir. Thank you.
Thank
I
you.
thank
Thank you.
Management Principal Dr. K. Srinivasan Sir, Head and Technology Center and Research Dr. I. Manju Ma'am, and our HOD Mr. S. Venkatesh Sir, and my colleagues for their constant support to organize these types of webinars. And on my own behalf, extend a very hearty thanks to all the participants for gracing your important work and sharing with us your findings and opinions today. Once again, I thank you all for making this webinar a grand success. Thank you.